10th Physical Science, Lesson Chemical Bonding, Topic Levi's dot structures. Why the chemical formula for water is H2O, why not HO2? And for sodium chloride NaCl, why not NaCl2? Normally chemical formula is H2O for water. So why we cannot write the HO2? And for sodium chloride NaCl, so why cannot we not write the NaCl2? So we will try to answer such questions in this chapter, chemical bonding. So when two atoms come close together, the electrons of each atom get the attractive force of the nucleus of another atom. Negatively charged particles are repelled and positively charged particles are also repelled. Positive and negative particles are attracted. So strength of attraction or repulsion decide the bond formation. So when we see the magnets, South Pole and North Pole is attracted, and both South Poles repel and both North Poles are repelled, but opposite poles are comes together, so they are attracted. So like this, here also we can see the negative particles when comes together, so they getting repelled. So when the positive particles are comes together, so they getting repelled. But the negative particles and positive particles comes together, so both of them are attracted. So strength of attraction or repulsion decide the bond formation. The nucleus and inner cells unaffected when atoms come close together. Electrons in outermost cell get affected. So here we can see the nucleus at the center of the atom, and around the cell inner cells are there and outer cells are there, but here nucleus and inner cells unaffected, but outer cell it is called valency cell, so it contains electrons, so they get affected. Next, Davis experiment. By using electricity, he extracted metals like potassium, sodium from salts. Metals migrated towards the negative electrode and the non-metal towards the positive electrode. Both charged particles are held together by electrostatic forces in compound. So in the beaker, sodium chloride solution is taken and negative electrode and positive electrode are kept inside this beaker. So when we send the electricity, so we observe the sodium is a metal, so the sodium particles are migrated towards the negative electrode. And chlorine is a non-metal, so it is also migrated towards the positive electrode. So both charged particles are held together by electrostatic forces in compound. So what is the compound here? Sodium chloride. In the periodic table we can see the 18 groups are there, and elements are divided into 4 blocks: S block, D block, P block and F block. So in the 18th group we can see the elements, noble gaseous elements: helium, neon, argon, krypton, xenon, radon. So first the element helium contains 2 valence electrons, neon 2, radon, all these elements contains valence electrons 8, 8, 8, 8. So it is clear that all the noble gases have 8 electrons in the outermost shell except helium. So here also we can see helium only contains 2 valence electrons. So the remaining noble gases elements contain 8 valency electrons. For example, argon is taken here. So the symbol of the element is argon, and valence electrons shown as a dots on each of the 4 sides. So 4 sides of the argon, so the dots are shown the valency electrons. Next example, sodium. So symbol of the element is Na. Valency electrons shown by a cross mark. So here we can see the cross mark above the sodium element. The Levi-Strauss structures of the noble gases. So helium contains 2 valence electrons, so 2 dots are there. Neon valence electrons 8 is there, 8 dots are there. Argon has 8 valence electrons, 8 dots are there. Krypton valence electrons 8, so 8 dots are there. Xenon has 8 valence electrons, 8 dots are there. Radon has 8 valence electrons, so 8 dots are there. Next, here is a table. So here 1, 2, 3, 4 horizontal lines are there. So first one element. So some elements are given here: hydrogen, helium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Fluorine and neon. And group number. Hydrogen group number is 1, helium group number 18, beryllium group number 2, boron group number 13, carbon group number 14, nitrogen group number 15, oxygen group number 16, fluorine group number 17, neon group number 18. Next, valency electron. Hydrogen valency electron 1, helium valency electron 2, beryllium valency electron 2, boron valency electron 3, carbon valency electron 4, nitrogen valency electron 5, oxygen valency electron 6, fluorine valency electrons 7, neon valency electrons 8. Next one, Levi's dot structure. So hydrogen valency electron 1, so 1 dot is there. Helium valency electrons 2, 2 dots are there. Beryllium valency electrons 2, 2 dots are there. Boron valency electrons 3, so 3 dots are there. Carbon valency electron 4, 4 dots are there. Nitrogen valence electrons 5, 5 dots are there. Oxygen valence electrons 6, 6 dots are there. Fluorine valence electrons 7. So, fluorine valence electrons 7, fluorine valence electron 7, so 7 dots are there. Next one, neon valence electrons 8, so 8 dots are there. Fluorine. So in the period table 1 to 17 group elements interested to get octet or ns to np6 configuration similar to that of noble gas elements. So 1 to 17. So in the period table 1 to 18 periods are there. So only the noble gases electron configuration NS2 NP6. So the remaining elements also interested to get the octet or NS2 NP6 configuration. Okay, it is similar to that of noble gas elements. Okay, so this is all about the Levi's dot structures.